Hello, and good morning, good afternoon, or good evening, depending on when you're watching this. I'm Mr. Snell. I'm a chemistry teacher in England, and I'm going to try to help Kenyan students who want to get through a good grade in their KCSE examinations at the end of Form 4, particularly. An area which a lot of students in the UK and in Kenya have problems with is moles. So I thought I would start with a set of little lessons on moles. And my first one identifies what a mole is and tries to help you have a simple way of calculating them. We're going to do some examples, and towards the end, it'll get a little bit more difficult, but not much. And then in the second program, we will just do some examples, and we'll look at a little practical to see whether this actually works in practice. I'm going to be using the board behind me. I'm going to be looking at a small experiment, as I said. I'm also going to be using this PowerPoint, which you will be able to access later. Here we go. Come on, slideshow, wake up. Here it is, and I'm going to be running through it for a little while. Like I said, you'll be able to use it yourself because that will be sent. Okay, so we're going to start with talking about what a mole is, but I'm not going to do it this way to start with. Okay, so the problem in chemistry is that we often use all sorts of chemicals. So if I look at a standard sort of experiment that you might have come across in a laboratory, you might have come across something like this. In this experiment here, I'm going to have 0.1 grams of magnesium. I've got some sulfuric acid. The sulfuric acid, I've got 50 cubic centimeters of a concentration called 1 mole per cubic decimeter or 1 mole per liter. And I'm going to try to measure the volume of hydrogen produced. Now, it'd be a lot better if what I could do was to work out, firstly, which one of these is going to be left over afterwards, and secondly, how much gas I expect, because if I don't expect enough, then it might push the plunger straight out of the syringe. So here we go. What we're going to do is I'm going to come back, I'm going to start to talk to you about what a mole is. Now, you probably know what a mole is. You're probably well aware of this. But what I'm going to do is I'm going to give you 3 different ways of calculating moles. First of all, though, why do we bother? Why do we bother about moles? Well, if I have, like this experiment which I'm going to be running, if I have the equation Mg, which is a solid, reacts with H2SO4, which is AQ, meaning dissolved in water. And you probably know, just for a moment, just think what the products are going to be. This is an acid and a metal. So it's going to produce a gas and a salt. And the salt is MgSO4, which is going to be dissolved in water, and H2 as a gas. Now, because of this, what we've got in this is we've got a solid, which is our first one. And our solid, the amount that I'm going to be starting with is 0.1 grams. Now, has that got more particles or fewer particles, more or less, than the sulfuric acid? In the sulfuric acid, I have 50 cubic centimeters of 1 mole per liter, or dm cubed. Is that more or less? Because in my equation it says 1 Mg reacts with 1 H2SO4. Otherwise it might say 2 here or something like that. And it's going to make one of these, and then it's going to make the hydrogen at the other end. And what we're going to try to do is to work out how many cubic centimeters of the hydrogen we're going to get. To start with, it's obvious that we've got these in 3 different physical states. And the way that we work out the moles of a solid is different from the way we work it out for a solution, which is different from the way we work it out with a gas. So what I'm going to do is I'm going to just run through that with you, how we actually do that. But that's where we're going. We're going to try to work out how much hydrogen we would produce. So just try and follow along. There's no need to make a lot of notes because it's going to be on the PowerPoint and you will get the PowerPoint anyway. And of course, you can stop this anytime. So here I am. I'm going to go back to my little presentation. I hope you can see this. And first we start by saying a mole is simply an amount of a chemical. That's pretty obvious. But what is it? Well, most of you will know that it's this very, very large number, 6 times 10 to the 23 of anything. It could be 6 times 10 to the 23 lions. It could be 6 times 10 to the 23 mammy wagons. It could be anything. It could be pints of milk. It doesn't matter. It's just a number. And it's a very big number because the particles themselves are very small, though the amounts that we weigh out or measure out are a little bit larger for them. So let's have a look at it. Well, when we talk about solids, we normally weigh them out. So you're probably familiar with a top pan balance or a weighing machine like this, and we put it on and it reads up here. Of course, we can find the mass of a liquid or a gas. That's not difficult either, and we can work out the mass of a liquid. That's easy, we just pour it in. A gas is a little bit more difficult, but for instance, if I took a balloon and I weigh it empty, and then I put a gas into it and we weigh it afterwards, that's one way of doing it. So we find the mass of a solid. So my moles is going to be something to do with masses. I'm color coding things here. Everything to do with solids is going to be green. When we come to a solution, we normally measure out the volume of a particular chemical, and we know its concentration as well. So there are two things to note here. It's got volume and concentration. This is solutions. This is when something is dissolved normally in water, and its volume and concentration. When we come to gases, it's normally a volume. So this is a similar experiment to the one I'm just about to do, or in the second program I'm going to do, where we've got an acid and some metal, a reactive metal, and it's producing gas which goes out here and fills up the space and pushes the plunger out. And that's the volume of a gas, okay? Now, what we need is a way of relating the quantities which we normally measure out, that mass or concentration of volume or volume of a gas, to something else that allows me to calculate the number of particles. And what I use with my own students is I try to have a very simple way of remembering it. And so here we go. Let's hope that it works for you too. So for a mass, if you remember from a periodic table, anytime you have a periodic table, there are two numbers. So for instance, if I have Na, there are two numbers. It doesn't matter which one is the higher, which is the above and which is below. The larger one is the mass number. Now, you probably know the mass number as the RAM. Most schools in Kenya use it call it the RAM. The RAM is the relative atomic mass. If we take the RAM, in the UK we often call it the AR. That's the atomic mass, but it's relative. If we take this in grams, this gives a mole. So if I take 23 grams of Na, that is 1 mole. That's easy, okay. And you probably know that. So in 23 grams of sodium, we would have 600,000 million atoms of sodium. So that gives us an idea of how to work out the moles. So we have a relationship triangle. The relationship triangle helps us a little bit concentrate on what it is that we have to do. And then it always allows us, if we've got two of the quantities, to find the third. They all look the same. They all look like this. You may have come across them if you do physics with voltage, current, resistance, and those sort of things. But in this particular example, I'm using mass. Moles goes here. We can shorten moles, but not much, just to MOL, but that's not terribly useful. Now, because we work in moles and we weigh out solids, we have to have mass in here somewhere. And the mass goes here, and it's normally grams, so that's the mass. Down here goes this number here from the periodic table, and it's the RAM. To find any one of these, I just cover up the one I want. So if, for instance, I've got the grams and the RAM, then I can cover up moles and it's grams over RAM, and I get the moles. If I want the RAM, I cover it up, it's grams over moles. If I want the grams, it's the moles times the RAM. It's really simple. But this doesn't look that easy to remember until, and one of my students a few years ago, who is now a very rich young man, so he was very clever, he came up with an idea. Now, in the UK, we have moles, which are little animals which live underground. And he went, moles dig holes. Okay, yeah, okay. And we went, oh, yes, okay. So moles dig holes, and they ram to make the holes. Moles ram underground. Now, that's pretty stupid, because we're not talking about ground, and this is not under. But it's a way of remembering it, and that's what you need in an examination, something to make things simple. Moles ram underneath ground. Moles ram underground. Oh, moles ram G. And that G isn't for ground, it's for grams. That's easy. And this could be RAM or MM for molecules, like CaCO3 doesn't have one on its own. We have to add up all the bits and pieces. So that's the first triangle. Now, in a minute, you'll see I'm going to put it on the PowerPoint. All three triangles are there, but that's the first one. So moles RAM underground. That's the first one. Now, the second one is for solutions. And I said that solutions. So, for instance, sulfuric acid. And in our example, we have 50 cubic centimeters of 1.0 moles per cubic decimeter. It's got two quantities here, so they must relate to the moles somehow. And I'm using these different colors because we're going to use them every time we do a calculation. So it has the same sort of pattern in that it's got a triangle and it's the same structure. It will help in your remembering things if you know that it's the same structure each time. We've just got to remember three triangles. Now, the silly thing about this one is, my silly way of remembering this is, if you remember from the green triangle, the one for solids, it was moles RAM underground. Well, this is solutions. Now, these guys, these moles, live underground. If I pour a solution onto the ground, they'll drown. So the moles come up to the top. Now, that's pretty stupid, right? But this is solutions. You just remember that the moles are at the top. In the solid, moles RAM underground. In the solutions, the moles are at the top. And the two other things, the volume and the concentration, go down here. It doesn't matter which side, does it? So this is concentration and this is volume. But there's something you have to remember, and that is we normally measure things out in cubic centimeters. In cubic centimeters, this is a measuring cylinder, and these are 50 cubic centimeters. They're quite small. But concentration is in moles per cubic decimeter. So we've got to do something to keep these the same. So what we do is we say volume over 1,000. That turns the volume into cubic decimeters. So that is to turn it into cubic decimeters. So the solution one, the moles have to come up to the top or they drown. And the only two things that you have are a volume and a concentration. So the concentration, volume, doesn't matter which way around. So if I want to know the moles, all I do is I say, hey, I take the concentration, 1, times the volume over 1,000. The volume is 50, 50 divided by 1,000. That's it. If I want to know the concentration of something, and I know how many moles there are, and I know the volume in cubic centimeters, then I can go, oh, the moles are the volume, sorry, the concentration is the moles over the volume. Just cover the one that you need. The third triangle, and the one we're going to need to check that we know what is happening in that little experiment, is the gases. And they're always volumes. Now, in the same way as for the masses, you never have to remember the periodic table. They'll always give you, here's a copy of a periodic table. They will always give you this so you can look up the detail. You can just go, oh yes, here we are. There's the mass of whatever it is. I don't have to remember that. And there's something else in this one that you don't have to remember. Same structure, just the same pattern. In this one, just like the solid one, because this is gases. If you take a mole and you drop it into a gas, it will go down. So the moles are here. It's a silly way of remembering things, but it works. So moles are here. Up here is what we measure gases in. And normally we measure it as a volume, and we measure it in cubic centimeters or mils. They're the same, cubic centimeters and mils. Down here is the number which you will be given, just like in the periodic table, finding the masses. And the number down here is 24,000 cubic centimeters. This is the volume of 1 mole of, and this is a little bit strange, any gas. Okay? So we've got the 3 triangles. Let's just look at them again. After that, there'll be a couple of little calculations to do. So here we go. So going back, the first thing that we've got to remember is that we weigh out, we find the mass of solids. Solutions always have 2 quantities. One is the volume and one is the concentration. And gases, it's normally a volume. As we said in the first one, we could weigh a liquid or a gas, but usually it's just solids and we find the volume of a gas. Here's the first triangle. Moles, ram, underground. Moles, ram or rum, G at the top. Moles, ram, underground. Silly way of remembering it, but it doesn't matter. Then there's the solutions. In the solutions, if we pour the solution on the ground, the moles, if they stayed down at the bottom, would drown. So they come up to the top. So the moles are up here. And the only other 2 things are the concentration and the volume. So volume over 1,000. And then we have the gases. And the gases, moles are back down at the bottom because they fall down through gas. And we have the volume, which is what we measure, over 24,000. Just sometimes they want the volume in cubic decimeters or liters. And this number down here is 24, not 24,000, but they will tell you that. So that is the beginning of moles. Now, using those 3 triangles, we should be able to work out almost anything. And now it's over to you. So what I'm going to ask you to do is to pause this in just a minute and have a go at these little questions here. It's asking, and these are, if you look at it, all masses, okay? So it's 4 grams here, 0.0055 grams, and 1 kilogram, that's 1,000 grams, of different chemicals. Now, just in case this is a little bit confusing or you need a little bit of help with this, I'm just going to start by just reminding you of something here. So here we go. So calcium carbonate, just in case you're not really confident with this, calcium carbonate is a solid CaCO3. You probably know this really, I'm telling you something you know already, but all you do to find the RMM of it is to add up all the bits and pieces that we've got. So 1 calcium weighs 40, 1 carbon weighs 12. And we've got 3 oxygens. The 3 is only the oxygens, not any other part of it. Weighs 16, so it's 16 and 16 and 16, 40, 52, Oh, look, that's a nice number, 100. So that is the RMM. M here, molecular mass, because it's a molecule, not just an atom. And therefore, 100 grams is 1 mole. In other words, with its triangle, moles would be down here, the grams is up here, and this down here is 100 because that is its RMM. Okay, so I'm going to ask you just to have a go at doing these little questions. Let's go back to that screen. So just stop the tape, stop the video just for a minute and have a go at these 3 here. Stop it right now. And when you start again, you will find here are the answers. Let me just move me out of the way. Here are the answers. The first one, 4 grams of NaOH. If you got it right, the answer is 0.1 moles. NaOH is 23 and 16 and 1, which is 40. So it's 4 grams over 40.1. 0.0055 grams of CaCO3. RMM we said was 100. So it's 0.0055 over 100, which is 0.000056, whoops, 5655, oh well, moles, or 5.5 times 10 to the minus 5 moles. I don't know where that 6 came from. 1 kilogram of water, well, 1 kilogram is 1,000 grams. Water is going to weigh 2 hydrogens, they're 1 each, and 1 oxygen, which is 16. So it's 1,000 over 18, which is 55.56. If you got those right, well done. So here are some ones involving volumes, involving solutions. So this is the concentration and volumes. This is the second triangle, if you remember. This is the one where the moles have to come up to the top and the concentrations and the volumes go at the bottom. And it's asking how many moles are there in 25 cubic centimeters of 0.5 mole per cubic decimeter HCl. And then the second one, a more difficult question, because it's asking you to do 2 things to use 2 triangles. If I dissolve 3.65 grams of HCl in 250 cubic centimeters of water, what's the concentration? Now, to do this one, you're going to have to think a little bit, but I'll just hint something to you. Okay, so here we go. This is a solution of HCl in water. And the solutions triangle looks like this. But there's a problem. They have given you the volume and they're asking about the concentration, but they haven't given you the moles. What they've said is 65 grams of HCl. Or was it 0.365? Sorry, I've got to check my own, got to share my own calculation. Yeah, 3.65, okay. So if I've got 3.65 grams, that's not moles. Oh, but wait a minute. This is grams. Ah, if this is grams, I can use the first triangle. That's the moles, gram or RMM underground. And this grams can go here. The moles, which is what we want, will be the grams over the RMM. Now, HCl is pretty simple. You need a periodic table, and you need to look up the mass of 1 hydrogen, 1 Cl, and add them together. So here are the questions again. What I'm going to ask you to do is I'm going to ask you to stop the video in just a minute. Wait a minute, where are we? So here are the 2 questions. Stop it on this bit here where you just write down the question and have a bit of a pause it on this and write down the question and have a go at these. This one, just 1 triangle. This one needs 2. I'm going to ask you to stop it now And in just a minute, I'll give you the answers. And here we go. Here are the answers. In the first one, we had 25 cubic centimeters of 0.5 mole per cubic decimeter HCl. The volume has to be in dm cubed, so that's why we put the volume over 1,000. The second triangle, because that's the red one, because it's a solution. Moles is concentration times volume over 1,000. So moles is the concentration 0.5 times 25 over 1,000. If you got the answer 0.0125, you are a chemist. And then finally, the more difficult one. From the second triangle, we know that we need concentration is moles over volume. So we need the moles and the volume. Now we've got the volume. The question, it says it gives you the volume, but not the moles. So we've got a mass, as I just said, so we use the first triangle, and the moles equals the grams over the RMM. The HCl RMM is 36.5, so it's 3.65 over 36.5, which is 0.1. If the volume is 250 cubic centimeters, that's 250 over 1,000 is 0.25. So the concentration is the moles over the volume, 0.1 over 250 over 1,000, which is 0.4. If you got 0.4, fantastic. If you didn't, stop it and have a look. That's the end of the very first of these little ones I'm going to do, because the next one I'm going to be looking at gases, and we're going to be looking at this little experiment and seeing whether we can predict what's going to happen. Okay, I hope that was useful. Remember your triangles, and they will make life easier. Bye for now.